So in the second video for 12.1, now that you guys have learned what the trig functions are, or I guess reminded yourself of what the trig functions are, now we're going to be using them to find missing side lengths and then find missing angle measures when we're looking at these right triangles. So first I'm going to give you guys these little setups. You know, you've got some pieces of a right triangle, some pieces that are there, some pieces that are missing. And notice these are 30, 60, 90 and 45, 45, 90 triangles. So we're going to be using those values that you had in your last video. So this one, we are going to compare the sides that we have compared to the sine, cosine, and tangent. So just to remind you guys of our sine, cosine, tangent, the SOHCAHTOA that you've probably known for years. If we're looking at a certain angle, you want to pay attention to what sides you do have so you know which of these three functions would be best to use. All right, so for 60, we've got the adjacent side and we have the hypotenuse. And so it makes the most sense, since we have the adjacent and the hypotenuse, to use cosine. So that's what we're going to set up. We are going to set up the cosine of this 60-degree angle here is equal to the adjacent side, which is x, over the opposite, over the hypotenuse, which is 14. Okay, so first thing we want to do is figure out how exactly we're going to get x by itself. So we're going to get x by itself by multiplying both sides by 14. So you multiply both sides of the equation by 14. These will cancel. And then you do have x by itself, but we still don't know what this is. So what we're going to do is use our values from yesterday. So remember, eventually we're going to have them memorized. For now, it's okay to flip back and take a look at what that value is. So we've got right here, the cosine of 60 is 1/2. Okay, so right here we can just use 14 times 1/2 is this value of x that we're looking for. So it just ends up being 7. So we've got x equals 7 would be our final answer here. And that should make sense, because note if we're looking at a 30, 60, 90 triangle, we noticed in our previous video that this short leg is always going to be half of the hypotenuse here. So 7 is half of 14. So let's do the same thing with this one. We've got our 45, 45, 90 triangle. We want to pay attention to what values we have. So this is the opposite right here, this 10 compared to this 45, and this is the hypotenuse. So with opposite and hypotenuse, we want to use sine. So we would have the sine of this 45-degree angle here is equal to the opposite, which is 10, over the hypotenuse, which is x. Okay, so here this one's going to be a little bit trickier because the x is in the denominator. And so I think this one actually might be best to evaluate this first. So sine of 45 degrees, we had that yesterday. Sine of 45 is root 2 over 2. Okay, so we're going to write this as root 2 over 2. And so the reason I think it would be best to set this up first is because we're going to cross multiply. So now we have these two fractions. So it's going to be super easy to just multiply these two together. So we get root 2 times x equals, and then multiply these two together. So we have 2 times 10, which is 20. All right, so what we're going to do is just divide both sides by root 2 and solve for x. And then we're going to end up rationalizing. So we don't have the square root in our denominator. So these will cancel. We'll have x by itself. But then this, we are going to rationalize by multiplying by root 2 over root 2. Remember, this is just a fancy one, but it clears the rationals from the denominator. So we have 20 root 2 over root 2 times root 2 is just 2. And finally, this 20 divided by 2 reduces down to 10 times the square root of 2. So that would be your answer. That is this missing side right here. Okay, so now that we're past these, we did the 30, 60, 90, 45, 45, 90. We can also just use our calculators if we have anything that's not those 30 or 45 or 60-degree angles that we're familiar with from the previous video. So this one, we've got to calculate a height of a building. Joel, shout out Joel, walked 200 feet from the base of the building and used an inclinometer, I don't know what this is, to measure the angle from his eye to the top of the building. All right, so we're going to make a little sketch here to help us out. So Joel walked 200 feet from the base of a building. Okay, so we've got building over here, right there. So Joel walked 200 feet from the base of a building. All right, so here's Joel. This is 200 feet right here. And then used an inclinometer to measure the angle from his eye to the top of the building. All right, so we're looking at this measurement right here, and this is the angle that he's talking about. So if the angle is 76 degrees, what is the distance from the top of the building to Joel's eye? So that is this measurement that we're looking for right here, which is essentially the hypotenuse of this triangle. So we know that this is a 76-degree angle, and this measurement right here is what we're looking for. So essentially we use all of this reference right here to just set up the scenario that we have, and we can do the same thing that we did up here. So based on this angle right here, we have the hypotenuse and we have the adjacent side, and so that would be cosine. So we can say the cosine of 76 degrees is equal to the adjacent side over the hypotenuse. All right, so in this scenario, it's best to make sure we get this x out of the denominator. So I'll multiply both sides by x. So these will cancel. And then to get the x by itself, we're going to divide both sides by the cosine of 76. And then this will cancel. So now we'll have the x by itself, and this right-hand side will be whatever 200 divided by the cosine of 76 is. So let me show you how this works on your calculator. Oops, a lot of glare. Okay, so you're going to be in a calculator page. And so you're going to just do 200 divided by, and you've got this trig menu. See over next to the 7, you have this trig menu right here. Hit trig and it opens up all 6 of your possibilities here. We're going to select the cosine of 76, and then the little degree button is with the pi. See all the way down here, there's this pi button right next to the h. And grab the little degree button, and there we go. So we get 826.7. And that would be in feet. All right, so that would be this distance right here that we just found, 826.7 feet. Make sure you use units, since it is going to be some sort of context. So like this measurement was given in feet, so we could give this measurement in feet. All right, next thing we're going to do is we're going to be able to find missing angles if we have all the sides. All right, so we've got these sides that we can find, and these are called the inverses of sine, cosine, and tangent, which if you notice the second row, when I hit this trig menu, see this whole bottom row right here? Those are called inverses. So you have sine inverse, cosine inverse, all the way down the line. So that's what we're going to be setting up right now. So if you know an angle, and you know the sine of that angle, then we can work our way backwards to figure out what the angle itself must have been. So we say if A is an acute angle and the sine of A is x, then the inverse sine is the angle. So we say the inverse sine of x is angle A. So we use that little measurement for an angle. So the inverse sine of x, we call that angle A. So this is what we could write kind of in expressions here. Okay, so we say if the sine of A is equal to x, then we say the inverse sine of x is equal to A. So inverse operations is basically just like swapping the x and y values like we did before. So those two just swap, and we switch it to our inverse function. So we also have cosine and tangent. We can do inverses for those too. So if we know A is the angle and we say the cosine of A is x, then the inverse cosine of x is A. Angle A. So we say this in symbols: if cosine of A equals x, then cosine inverse of x equals A. And I know you guys have had some experience with this before. I don't know how, right in your minds it is right now. Okay, same thing here. If A is an acute angle, the tangent of A is x, then the inverse tangent of x is A. Angle A. Okay, so last one. If tangent of A is equal to x, then inverse tangent of x is equal to A. So those just go back and forth. They work also for secant, cosecant, and cotangent if we ever needed to use those. So let's look at some examples. Notice these ones, it's the angles that's missing, but we have all the sides. So pay attention. This, we are given the adjacent and the hypotenuse. That would be cosine. So you would say cosine of x is equal to, and we do the adjacent over the hypotenuse, so 15/7. So basically use this statement. It says cosine of x equals 15/7. Then to find A, we just switch it into this format. So we can basically say, like, if we know that this is true, then we know that cosine inverse of 15/7 is equal to x. We just swap it. So we started with this format, we just swap it into this format, and so this can just get plugged into our calculator if we want to figure out what x is. So that's exactly what we're going to do. Right in this menu here. So you've got your, there we go, cosine inverse. We type in 15/17. I'm just going to double check that we are in degrees. Oh, we are not. Okay, so some of us might have to change our calculators into degrees if they're not automatically in degrees, and I can do that for you during class. All right, so we do this. So we come up with 28.1. So that would be the degree measurement, would be 28.1. Okay, so that would be this angle right here. So let's do the exact same thing for this one. So with this one compared to x, we have the other two sides besides the hypotenuse. So we have the adjacent and we have the opposite. So that would be tangent. So let's set up an if-then statement. So if tangent of x degrees is equal to, and we have opposite over adjacent, then, so we have this statement right here. This statement, we're just going to switch it up. So we can say tangent inverse of 27 over 18 is equal to x. And so this statement right here, we can just plug that right into our calculators and we'll figure out what x is. All right, so hit that trig button right next to the 7. Go over to tangent inverse, type in 27 over 18, and that gives us our angle measurement. So that would be 56.3 degrees. Okay, so that's how you use inverse operations in order to come up with angles if you have side measurements. Last little thing we're going to do is kind of like some story problems just to set up what the angles and sides would be. All right, so angle of elevation looks like this. Angle of elevation is if you like start here and then you look up towards something. That would be this angle measurement right here. Angle of depression would be if you start up and then you look down towards something. So if you're talking about angle of depression, that would be that angle like that. So it's basically whether you're like on a lower level looking up versus a higher level looking down. That's what they call them, either angle of elevation versus angle of depression. Okay, so let's look at this one. Golfer is standing at the tee looking up to the green on a hill. Okay, so that's definitely going to be an angle of elevation. So he's looking up to the green on a hill. So you can look at something like that. The tee is 36 yards lower than the green. Okay, so that would be this measurement right here. The angle of elevation from the tee to the hole is 12 degrees. So that's this measurement right here. From a camera in a blimp, the apparent distance between the golfer and the hole is the horizontal distance. That is this horizontal distance right here. All right, so just basically looking at it, like not this measurement, but we're looking for this horizontal distance. So let's use h for horizontal distance. So that's what we want to figure out. All right, so if we look at 12 degrees, we have the opposite and hypotenuse, so we would use tangent. So we're going to say the tangent of 12 degrees is equal to opposite over adjacent, and we're going to solve for h. Okay, so remember to get that h out of the denominator, you've got to multiply it to both sides first. So multiply it to both sides, get it to cancel, and then to get the h by itself, we'll divide both sides by tangent of 12 degrees. Okay, so here these will cancel out. So h will be whatever 36 divided by the tangent of 12 degrees is. Okay, remember this is like 1 unit. You can't reduce or cancel the 36 with the 12. Tangent of 12 is just going to be some weird decimal value. So let's set this up. I'm going to set up a little fraction by hitting Control and then the divide symbol. And we're going to type in 36 divided by the tangent of 12 degrees. We get 169.4. 169.4. And that would be in yards. So when it's a story problem like this, make sure you always have any measurements or any units that they would give to you. All right, very last one on the next page. Got a 14-foot long ladder placed against a house at an angle of elevation of 72 degrees. So we've got house, ladder, kind of set up like that. So there's our 14-foot long ladder. Here's our 72-degree angle. How high above the ground is the top of the ladder? Okay, so let's use, I don't know, T for top. You can always use X if you want to, or you can change the variable up, whatever you're feeling. So we've got, in reference to the right angle, we have the opposite and we have the hypotenuse. So that is going to be sine. So we have the sine of 72 degrees. According to this, T is the opposite and 14 is the hypotenuse. So all we have to do with this one to get the T by itself is just multiply both sides by 14. So we can just plug that left-hand side right into the calculator like that. So we would have 14 times the sine of 72 degrees, and we get 13.3. Oops, there it is. 13.3 feet. All right, so that is it for your right angle stuff.